First question deals with the mid-segment of a triangle. So DE is the mid-segment that runs parallel to BC. And what we know is that the mid-segment that runs parallel with that side is going to be half of its distance. So the length of DE is going to be equal to half the length of BC. Alrighty, so if like DE was like 5, then BC would be like 10. That's that relationship with the mid-segment of a triangle. Cool, so if you look here, the length of BC is the distance from 0, 0 to Q, comma 0. And that distance is horizontal, so we're looking at the change in our X. So the length of BC there is equal to Q. So if the question asks you, which it doesn't, if it asks you what the length of DE was, it would be half of Q. Okay, just in case you ever saw a question like that, you would know that you could divide variables as well as numbers. So the best choice for this question is going to be that DE equals half of BC. In this next question, they ask for the length of HI. So the first thing we need to do is say, hey, HI, when combined with IJ, adds up to the big segment HJ. We call that the segment addition postulate. So now we can substitute the lengths or values there. HI is 2x plus 10. So let's replace HI with 2x plus 10. For IJ, it's 3x plus 7. And HJ is 8x plus 5. We call that the segment addition postulate, and we always said, you know, the part plus the part equals the whole. So you probably remember that. All right, so for the algebra, we've got to combine some like terms. We've got a 2x and a 3x that make 5x, and a 10 and a 7 that make 17. Now I want to get all my x's on one side, so I'll subtract 5x. And I'll have 17 equals 3x plus 5. And then I'll move that plus 5 over by subtracting 5. And I've got 12 equals 3x. And you know that x is going to equal 4. But the question doesn't ask for x, it asks for HI. So we have to take that 4 and plug it back in. So I know that HI was equal to 2x plus 10. Plugging in the 4 for x, that's 2 times 4 plus 10. 8 plus 10 is 18. Problem number 3 deals with angle AEB and angle DEC. So hopefully you look at those and you're like, yep, those are vertical angles. Oops. Vertical angles. Alrighty, and we know that vertical angles are congruent. So I know that AEB, which is 2x plus 32, is going to have to be equal to DEC, which is 1/2 x plus 65. Oops, 65. There it goes. So again, just like the previous one, I want all my x's on one side, so I'll subtract 1/2 x. If you want to use 0.5 instead of 1/2, that's fine. Because 2x minus half an x is 1.5x. All right, so I got 1.5x equals 65 minus 32 is 33. And then lastly, divide by 1.5. Make sure you bring your calculator to the exam. And x equals 22. In that problem, all you had to do was find x. Alrighty, question number 4. Line R and S are parallel. Then all of the following statements are valid except one of them. So this is going to be our whole corresponding angles, alternate interiors, alternate exteriors, and same side interior angles. So we've got to know all about those guys. So 3 and 7 are supposed to be congruent to each other, according to A. Are they really? Is angle 3 congruent to angle 7? Yes, because they're corresponding angles. Is angle 1 congruent to angle 5? And the answer is yes, because those are corresponding angles. And then is angle 1 congruent to angle 7? And the answer is yes, because those are alternate interiors. And then is angle 3 congruent to angle 6? Angle 3, and then here's angle 6 over here. Are they congruent to each other? And the answer is no. Alrighty, angle 3 is an acute angle, angle 6 is an obtuse angle. They're not going to be congruent. So that's the one that doesn't work.